Hello, welcome to the episode of this week. And today we will look into the question, what makes large language models so powerful? So first, you should understand that neural networks are nothing else than billions of numbers between 0 and 1. So sometimes clients ask me, but where is the data? Is the database connected? Or where does it have the information, for example, in terms of the number of people living in a city when I ask them for how many people live in Los Angeles? And the answer is that based on this input for the question, how many people live in the city Los Angeles, then the neural networks, the neurons are triggered and the output is generated. But this only based on this information that you have in the neurons, and these are just numbers between 0 and 1. But they have been trained, for example, of huge amounts of data, so they have this knowledge in these numbers, more or less. So now the question is, how are these networks trained? So usually for training, if you have supervised learning, you have labeled data. If you want to train a neural network that you can classify between cat images and, for example, dog images, what you need is labeled data. That means that you need a lot of images, thousands of images, where someone has said, is this a cat or is it a dog in the image? And based on this data, you can then do a hot encoding, meaning you have a vector of a size of 2, saying, for example, if there is a cat in this image, the first line is 1, the second line is then 0, because there is 0 dog and 1 cat in this image. If there is a dog in this image, it would be the other way around, for example, 0, 1. And then based on this is the output that you have. You take all the pixels of this image, it's a 30 by 30 image with all these pixels, then you feed it into the network, and then you train it, that you try to generate this 1, 0, if there is a cat in this image. And based on all this pixel information, you train the neurons in the network, these numbers between 0 and 1, that they are in such a way that this output is generated and nothing else it is. So now let's not talk about images, let's talk about text. Because the genius thing about text is that you do not have this tedious work of generating this labeled data, saying or asking the question, is it a dog, is it a cat? Because for this you need humans. In text, the great thing is that you have labeled data per se. That means if you have the sentence, this is a beautiful day, and you, for example, want to put it into such a neural network and such a large language model to train it, what is the labeled data is that every word in the sentence is a label. This is a beautiful day. What you would do is you feed in, this is a beautiful, and the output should be day of this is a beautiful day because, and then the input would be, this is a beautiful day, and the output should be because. And when the researchers found out that text per se is labeled data, it was a great thing, because you do not have the tedious work of labeling data. So, and this is why currently, in order to train such a base model, or to improve a base model, you need huge amount of data. For example, 10 terabytes of data, you feed it in, you train this network, you try to optimize it in a way that the neurons are generated in a way that, for example, the input fits the output. And after you've done this on huge clusters, which cost millions of euros or dollars, and it takes a lot of time, you need a lot of GPUs, for example, 6,000, then you have this base model of this large language model, which you can use then. So, and now what, for example, the difference is between a Facebook open source model that you get, for example, where you have all these weights, where you have all these neurons, billions of neurons, right, where you can look into, which you could further improve or manipulate. What OpenAI does is it does not give you this base model, but it does a lot of fine-tuning for you. If you have an open source model, such a one from Facebook, you have to do the fine-tuning by yourself. But for example, OpenAI does a further fine-tuning, meaning that they also generate labeled data in order to fine-tune, to further optimize this model. Maybe you see it sometimes if you use ChatGPT. ChatGPT sometimes generates 2 answers and then asks you, for example, which one is better. And by answering there, you generate label data for OpenAI, which they then use in order to further improve the model. So They do more or less human-assisted labeling. Sometimes they use us for this, right? But they further fine-tune the model, and they do it on a high frequency. That means, for example, every week. And during this time, they also gather all the data you feed in, for example, by asking question as to use it as further labeled data for text, as text, right? Because text, as I explained before, is per se labeled data. They use it to further train the base model, right? And this base model training is done 1 or 2 times per year. So, and why do they do it? Because the more data they use, right? This is the performance formula of large language models. The more data they use and they feed in, the better the model gets. And in order to increase the performance of also the knowledge of the model, they have to increase the number of parameters in the networks. That means adding further parameters, which can be between 0 and 1. And the bigger the network is, the better is the output, right? And this is currently the run that we have, that they try to train bigger and bigger networks. For example, the new Facebook model, the Llama 3.2 is bigger than the one before, because this is the run that you see at the moment, that you try to make these networks bigger in order to increase the performance. Okay, I hope you enjoyed this episode, and maybe you are now a little bit smarter in terms of neural networks. If you have any further questions, reach out to me or leave a comment on the YouTube channel, and then I will answer the questions. So see you next week in the next episode.